Deep beneath the ocean, far from sunlight or any sign of human life, there are massive machines, silently patrolling the seas. These are nuclear submarines, incredible vessels that can stay hidden for months, generate their own oxygen, and travel across the world without ever needing to surface. But how do they actually work? Let's dive deep into the fascinating technology behind these underwater giants. Unlike traditional diesel-electric submarines, which must surface or use a snorkel to take in air for their engines, nuclear submarines are powered by nuclear reactors. These reactors use uranium fuel to generate enormous amounts of heat through controlled nuclear fission. The heat turns water into steam, which drives turbines that create both electricity and propulsion. This means a nuclear submarine can theoretically stay underwater for years, limited only by food and crew endurance, not fuel. Let's start with one of the most mind-blowing features, their ability to make oxygen. Humans can only survive minutes without oxygen, yet submarines operate completely sealed from the outside world. Nuclear subs solve this using electrolysis, a process that splits seawater into hydrogen and oxygen. The oxygen is pumped into the air supply, while carbon dioxide exhaled by the crew is removed using scrubbers filled with chemicals like lithium hydroxide. This creates a safe, breathable environment, even hundreds of meters underwater. Water is another basic need. Submarines use onboard distillation systems to turn seawater into fresh drinking water. Nuclear power provides unlimited energy to boil and purify thousands of liters of water daily. This same water is also used for cooling the reactor and other systems. So if oxygen and water are unlimited, what limits a submarine's underwater time? The answer is food. Nuclear subs can carry massive amounts of packaged and canned food. But after around 90 days, supplies start running low, and the submarine usually surfaces or resupplies. Let's talk about navigation, because GPS signals don't penetrate deep ocean water. Submarines rely on a combination of sonar, which uses sound waves to map surroundings, and inertial navigation systems, which track movement and orientation. The submarine is constantly listening to the ocean with passive sonar, detecting ships and objects from incredible distances, while active sonar, which sends out pings, is used carefully because it can reveal the sub's position. The interior of a nuclear submarine is like a small, self-sustaining city. Space is extremely tight, with crews often sharing bunks in shifts, a practice called hot racking. Lighting is artificial, and days are divided into work cycles instead of natural daylight. Crews are carefully selected and trained to handle months of isolation in confined conditions. Entertainment is limited but essential, with digital libraries of movies and books on board to keep morale up. Safety is a top priority, especially with a nuclear reactor on board. These reactors are incredibly well shielded and designed to withstand accidents. Submarines also have multiple watertight compartments, allowing the crew to seal off sections if flooding occurs. In over 60 years of operation, nuclear submarines have proven remarkably safe, and most incidents have been due to human error or collisions rather than reactor failures. Another fascinating part of submarine operations is stealth. Submarines are engineered to be nearly silent. Their propellers are specially designed to minimize noise, and the entire hull is coated with sound-absorbing materials to avoid sonar detection. Some submarines can cruise silently at just a few knots, effectively becoming invisible to most detection systems. Let's look at their missions. Nuclear submarines are primarily used by major world powers for two reasons: stealth reconnaissance and nuclear deterrence. Some subs carry ballistic missiles with nuclear warheads, making them part of a country's ultimate defense strategy. These subs can hide in remote parts of the ocean, ensuring that even if a country were attacked, they could retaliate. Others are attack submarines, designed to hunt enemy ships and submarines, gather intelligence, and support naval operations. The scale of these machines is astonishing. Modern nuclear submarines are often longer than a football field, displacing more than 10,000 tons of water. The crew, typically around 100 to 150 sailors, live and work in a space far smaller than a commercial airliner's interior. Every inch of the submarine is used efficiently, with complex wiring, pipes, and machinery filling almost every compartment. Life on board is challenging. Crew members work 6-hour shifts around the clock, and there are no windows. The submarine feels the same whether it's 2 a.m. or 2 p.m. Over time, submariners lose their sense of natural time, relying entirely on routine and artificial lighting. Mental health and teamwork are critical, so submariners undergo extensive psychological screening before deployment. Nuclear submarines are technological marvels, combining nuclear engineering, advanced sonar, stealth design, and life support systems into a vessel that can remain submerged for months. They're like self-contained underwater cities, designed for extreme endurance, stealth, and survivability. To put their capabilities into perspective, a nuclear submarine can travel hundreds of thousands of miles underwater without refueling, maintain a constant air supply, and even launch missiles from deep below the surface. In many ways, they represent one of humanity's greatest engineering achievements, a perfect balance of science, strategy, and survival. Would you spend months underwater aboard one of these machines? Let us know in the comments. And if you enjoyed learning about these fascinating vessels, don't forget to subscribe and turn on notifications so you never miss the next deep dive into amazing technology.